Section 5.1, an overview of the area problem. Let's look at what the area problem is. It says, given a function f that is continuous and non-negative on closed interval AB, find the area between the graph of f and the interval AB on the x-axis. All right, basically here's what they're saying right here. Here's the problem. We have a function y is equal to f of x, maybe some curve like that, okay? And we're looking for the area between that curve and the x-axis between A and B right here. So the shaded region. How do I find that area there? Well, sometimes this is very, very complicated, okay? Now, you wouldn't have a problem at all if we had an x-axis here, a y-axis there. We had a curve that looked like this, y is equal to f of x. And here was A, and here was B, and I had to find this area right here between the curve and the x-axis and between A and B. Well, if this was a horizontal line, then this shape would make a rectangle, and you would just say, let me find length times width of my rectangle. That wouldn't be a problem at all. But this is not a rectangle at all because of this curve. That's where the problem comes in, okay? So for shapes like this that we have formulas for, it's nice and easy, and we're going to look at some of that in a little bit, okay? But for shapes like this where it's more difficult, where you have that curve, here's what we're going to be doing in this section to find or estimate the area under this curve. We're going to take this shape and we're going to break it into rectangles, okay? Like we're going to take this, we're going to break it up like this, and we're going to break it up maybe like this and like this. So we're going to partition it, okay? And maybe we'll draw a rectangle like this, a rectangle like that, a rectangle like that, and a rectangle like that. And we'll estimate the area under the curve by finding the area of each one of these rectangles. Now notice they're a rectangle if I make them, what, rectangular, like square at the top instead of curved at the top, right? And then what I could do is I can estimate the area under the curve because the area of a rectangle is easy. I just multiply length times width, right? That's what we're going to be doing here basically. All right, so let's look at the first example. They talk about the rectangular method for finding the area. Then it says, let f of x be equal to x squared plus 1 for x is greater than or equal to 0. Find the area under the curve between 0 and 1 by using, and then we have parts A, B, and so forth, okay? All right, so part A. They want me to find the area under the curve, f of x is equal to x squared plus 1, for x is greater than or equal to 0, but between 0 and 1 on the x-axis, okay? So let's draw a picture of what this looks like. All right, here's my x-axis, here's my y-axis. X squared plus 1 is going to be what? A parabola shifted 1 unit upward, right? No, let me draw that a little better here. Get sloppy with my drawing. So that's maybe something like that, okay? F of x is equal to x squared plus 1. And they want me to look for the area between 0 and 1. So between 0 here and 1 here, okay? I'm going to make it kind of wide so I have enough room to draw stuff. So maybe I'll make it even wider. Maybe I'll say, let me put 1 there just to give me more room to draw. All right, now what did they say in part A? They say by using 2 rectangles, right? Let's estimate this area between the curve and the x-axis here and between 0 and 1 here. So I'm looking for this area right in here, okay? And I want to estimate it by using 2 rectangles. So what I might do is I might say, okay, one rectangle is going to look like this. One rectangle is going to be like this. And let me break this in half, this interval right here. And now it's my choice how I draw a rectangle. I could draw a rectangle that starts at the left-hand side of this curve and goes right. And then this rectangle would start at the left hand of this curve and go right. Or I could start at the right hand of the curve and go left. It doesn't specify, so I'm just going to do this one. I'm going to have a rectangle here, right? Well, let me stay consistent. Start at the right hand side and go like that. All right, so what I'm going to do is I'm going to estimate the area under the curve by finding the area of each one of these rectangles. Now think about this. If I find the area of each one of these rectangles, I'm going to have an overestimation of the area under my curve. Because here's my curve. The area under it's this stuff, right? Whenever I calculate the area of my rectangle, I'm going to calculate this and that, this and that. So these two parts are going to be overestimation. But that's what they tell me to use. So if I split this interval exactly in half, this would be 1/2 right here, right? All right, so I'm going to say area. Area is going to be approximately, how do I calculate the width of each rectangle? Or how do I calculate, the area of each rectangle? Width times length, right? So what's the width here? From 0 to 1/2. 1/2 times, what's the length right here? The length, how tall is this rectangle from here to here, right? So how tall is that? How do I find that? Well, here's where it hits my function, right? Here's my function, f of x. So couldn't I say the height of that is my function f evaluated at 1/2? And that'll be my height right there. So that's the area of this first rectangle. Plus, I need to put in the area of my second rectangle. How wide is my second rectangle? 1/2 times, how tall is it? Is this tall, right? And what is that? That's my function f right here, my curve f, evaluated where? At 1. So times f evaluated at 1. So that's approximately 1/2 times, what's f at 1/2? We'll just evaluate f at 1/2. So 1/2 squared plus 1. 1/2 squared plus 1 plus this 1/2 times f evaluated at 1. So 1 squared plus 1. And just do the math here, okay? So that's 1/2 times 1/4 plus 1 plus 1/2 times 2. And what does that give me? 5/4. 5/4 times 1/2 is what? 5/8. Plus what? 1. So what does that end up giving me? 8/8 plus 5/8. So what is that? 13/8 is approximately my area. And I could say, okay, it's approximate anyway. So I could put the decimal 1.625. And it depends on what Wiley asks you for. Does it ask you to round the decimal or what, or does it want the fraction? Either way though, it's approximate because I'm not finding the actual area under the curve. I'm finding the area of the rectangles. Let's look at B. B tells me to do that same thing, but this time use 4 rectangles, okay? So I'm going to take exactly the same figure I had before. So I'm taking exactly the same figure I had before. F of x is equal to x squared plus 1. I'm going to look at the area between 0 and 1 again. Between 0 and 1, the area between my curve and the x-axis here, okay? But this time, what does it tell me to do? It tells me to use 4 rectangles. So I'm going to split this area right here into 4 rectangles. So let me draw this part real quick. Okay, now let me bust this up into 4 rectangles. So maybe it looks like this, this, and this, and that'll allow me to draw 4 rectangles. Now, for this rectangle right here, I'm going to make the top starting where it hits the curve at the right and going left. And then I have a rectangle. This one, stay consistent where you hit the curve at the right and go like that. For this rectangle, hit the curve at the right, go left, For this rectangle, it's curve to the right and go left. So if I find the area of each one of these rectangles, I'm going to have an overestimate because of this, 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 and this, right? But it's what they tell me to use, okay? All right, let's see where I'm at on the x-axis here, here, here. Well, if I took 0 and 1 and I split it in half, I'm at a half right here, right? So splitting from 0 to 1/2 and half again, I get a fourth, right? And wouldn't that be 3/4? All right, so they want me to estimate the area under the curve using those 4 rectangles, okay? So let's find the area of those 4 rectangles. The area under my curve is approximately equal to the area of each one of these rectangles. Now, how do I find the area of these rectangles? Width times height. What's the width of this one? 1/4. And what is the height of this rectangle? It's this tall, right? So it's where it hits my function f at what? 1/4. So the height is f at 1/4. So that takes care of that rectangle. My next rectangle now, what is the width of it? 1/4 to 1/2 is what? 1/4. So I have the width. What's the height of it right here? My function f evaluated where? At 1/2. So that was the area of my second rectangle. Let's add to it the area of my third rectangle. How wide is this rectangle right here? 1/4 again? How tall is it? F evaluated where? At 3/4. So I took care of this rectangle. What about my last rectangle? It's going to have a width of 1/4. It's going to have a height of f evaluated at 1. Now, just to make things look a little neater here, notice how they all have a factor of 1/4, okay? So what I'm going to do is I'm going to factor out that 1/4. So if I factor that out, I'm left with f at 1/4 plus f at 1/2 plus f at 3/4 plus f at 1. So that gives me 1/4 times, what's f at 1/4? We'll sub in 1/4 into this function. So we have 1/4 squared plus 1. Plus f at 1/2. So substitute or evaluate this function in 1/2. So 1/2 squared plus 1 plus f at 3/4. So you have 3/4 squared plus 1 plus f at 1. So you have 1 squared plus 1. All right, at this point, just plug all this stuff into your calculator, okay? And what if, it didn't tell me how far to round, but what if I round to, say, 3 decimals? I get 1.469. And that's approximately my area under my curve, but I have an overestimate because I'm calculating the area of that stuff above the curve. The actual area of this thing, by the way, is like 1 1/3. So you can say like this, the actual area. So which answer was closer to this actual area here under the curve? Like in other words, the actual area under this curve is about 1.33333. It's exactly 1 1/3. So was this answer closer to the actual area or was my first one? Well, this one was, and why? Because we drew more rectangles here, and therefore we had less area over the curve, right? So in general, the more rectangles you put in here, the better your estimate is going to be.